Welcome to Vision Plus and welcome back to this Uniform Mathematics. We are looking at how we can find the length of a tangent from a given point to a given circle. Example 5, part A, the circle is x squared plus y squared minus 2x plus xy minus 15 equals to 0. And then this is the point where the tangent is drawn to the circle. So to make our work simpler, we draw a circle. Then we say, assuming the tangent touches the circle at this point and it is coming from this point. So the point where the tangent is drawn is 4, 1. It has those coordinates. So let me call this point B for our case, but you can use any other letter. And then this point where the tangent meets the circle, let me call it point A. Now we have our center here, and our radius is perpendicular to the tangent, makes 90 degrees here. What are the coordinates of the center? We have the equation of the circle here, expanded equation, and we can get the coordinates of the center. Please go on and compare terms and coefficients. But the center in this case is 1 and negative 3. After getting the coordinates of the center, we need the radius because it is important to find the length AB. It will help us in finding the length of the tangent AB. Since it is in the expanded form, the center is known as 1 and negative 3. So we know that the sum of constants C is given by A squared plus B squared minus R squared. What is C? C is negative 15 equals to, what is A? A is 1 squared plus, what is B? Negative 3 squared and then minus R squared. In this manner, we can find the radius. So 1 squared plus negative 3 squared. Take this on that side, plus 15. So I'm getting the radius in this case as 5 units. So after getting the radius 5 units, it means this distance is 5 units. Now we need to find the distance or length CB so that we can use Pythagoras theorem to get the length AB. So the length CB, which in this case is the distance between 2 points given by this formula. Now we need to substitute. Let me call this x1, y1, x2, y2. So substitute for x2 minus x1. x2 is 4 minus x1 is 1, 4 minus 1 squared plus y2 is 1 minus y1 is negative 3 squared. Then it close the calculator. 4 minus 1 squared plus 1 minus negative 3 squared. I'm getting 25, and then you take the root, I'm getting 5 units. So the length CB is 5 units. After getting that, then we need to apply Pythagoras theorem to give us AB. So applying Pythagoras theorem, which says that the sum of the squares of two shorter sides equals to the square of the longer sides. So the two shorter sides are AB and AC. We square them and add them, they give us the longer side CB squared. We are looking for AB, which is the length of the tangent AB squared plus AC. AC is the radius, which is 5 squared equals to CB is also 5 squared. That means here AB squared equals to 5 squared minus 5 squared. So AB squared equals to 0. Taking the square root, we are finding that AB equals to 0. So therefore, the length AB is 0 units. From here up to here is 0 units. What is the meaning of this? If the length of the tangent is 0, it means that this point is lying on the circle. So this point B is not actually far away from the circle. It is on the circle, such that the distance between the circle and that point is 0. Any point which is lying on the circle is 0 distance from the circle. Therefore, the length of the tangent is 0 units. And we say that this implies that the tangent lies on a point on the circumference of the circle. So it means that this point from where we are drawing the tangent is not here, but it is on the circle at that point of tangency. So this is the solution for, and now going to part B. Part B, the circle is 2x squared plus 2y squared minus 8x plus 4y minus 10 equals to 0. This is the given circle. Remember, when we are doing circles, I warned you that seriously, that always the coefficients, okay, of x squared and y squared must always be 1. Let me quote it again here. Coefficients of x squared and y squared must always be 1. For x squared and y squared, they must together be 1. So what can we do to make them 1? So that we make this equation a standard equation of the circle. What we can do is to divide all terms by the coefficient 2. So dividing all terms by 2. That means that we shall have 2x squared divided by 2 plus 2y squared divided by 2 minus 8x divided by 2 plus 4y divided by 2 minus 10 divided by 2 equals to 0 divided by 2. Then we simplify. This here now gives us x squared plus y squared minus 4x minus, no, plus 2y minus 5 equals to 0. Now this equation is in the standard way that we need it as equation of the circle. So after making that, then you draw your circle, and then you say that the tangent meets the circle at that point. Use a ruler at that point. Use a ruler. So I'm going to call this point. This is the point where the tangent is drawn from point 5 and 4. So let me call this point B in this case. Then let me call the point where the tangent meets the circle point A. Now we have the radius which runs from the center up to where point A is. This is the radius. Please use a ruler, and then this is angle of 90. Now we need the coordinates of the center from this equation. So you can go on, compare terms and coefficients, and then we get the coordinates of the center. Please get it before we continue. Now my points are 2 and -1. These are the coordinates of the center. So let us find the radius so that we can go on to find the length. This is the length we are looking for. This is the length of the tangent, length AB. So for us to get the radius, we know the formula that C in the expanded form is given by A squared plus B squared minus R squared. What is C? C in this case is -5. So negative 5 equals to, what is A? A is 2 squared plus, what is B? B is negative 1 squared, then minus R squared. Then you press the calculator or work out R. So 2 squared plus negative 1 squared and then plus 5. So I'm getting my R here as root of 10 units. I'm getting root of 10 units. So the length SC or CA, which is the radius, is root 10. Now we are looking for the length AB. So let's get the length CB to help us in finding the length AB. So the length CB is the distance between 2 points, which is the center, and then the point from which the tangent is drawn. So the length CB, is given by x2 minus x1 squared plus y2 minus y1 squared, in that manner. And then you substitute for these values. x2 is 5 minus 2, 5 minus x1, which is 2 squared plus y2 is 4 minus negative 1, 4 minus negative 1 squared. Then you place the calculator. 5 minus 2 squared plus 4 minus negative 1 squared. I'm getting 34. So here we are getting root of 34. 5 squared plus 3 squared. Yes. So the length CB is 34 units. Our board is disturbing. This length here is 34 units. So we need to apply Pythagoras theorem to give us the length AB. So in applying Pythagoras theorem, we shall say A squared, we shall say AB squared, we know that already, plus AC squared equals to CB squared. It means that the sum of the squares of the two shorter sides, which are AB and AC, equals to the square of the longer side, AC. No, CB. The longer side is CB. Then we substitute. We are looking for AB, so we take it there, plus what is AC? AC is the radius, root of 10 squared equals to CB is length 34 squared. And means our AB becomes, subtract the two roots, 34 minus 10. I'm getting root of 24 because root of 34 squared minus root of 10 squared is 24, but then you take the square root on both sides to give you root of 24 units. Now that is the length AB, and that is the length of the tangent from point B. Therefore, the length of the tangent, which in this case we have called AB, is root of 24 units.